Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 17 and we'll be talking about Terraform. Like we'll understand various things about Terraform, how to install, how to configure, write your first Terraform project. I'll also show you how to instead of creating your state file in local, how to put the state file into a remote backend. And we will talk about Terraform modules. We'll talk about problems with the Terraform and problems with the Terraform state file, and we'll finally look at some Terraform interview questions. And all of these things are put together with my experience, and it took a lot of time for me. So what I've done is, for somebody who is not able to follow these things, let's say you watch the video but for some reasons the video was not clear to you, then you can also go ahead and look into this repository. Okay, so I have put together all of the things that we are discussing today in a Git repository, including the configuration files like the Terraform files, the projects that we are going to create, both using local state file and remote state file. Okay, so these are the configuration files as well. You can clone this repository and you can execute the actions by yourself as well. Okay, so the repository holds everything like the images that we are discussing, the examples, whatnot, everything. So fork this repository so that you get a gist of what we are doing as well. Perfect. So if we go back to the discussion yesterday, okay. So what did we discuss yesterday? We talked about infrastructure as code, right? Then we talked about the concept of API as code and how Terraform actually executes these things and Terraform automates your infrastructure. So today I'll try to put these things in as practical ways as possible so that you understand the realistic example of Terraform. And we will also take a look at what is a good Terraform setup. How does a good Terraform setup look like? So I'll explain you using AWS, but the same things apply for Azure as well. Okay, so many people have been asking me about Azure. So whenever I explain AWS, the cloud providers are all the same. It is matter of today we'll be talking about S3 as remote bucket, and in Azure you can use your Azure storage account and you can use your Azure storage container. Just replace S3 with Azure storage container, then your concept will be the same. Okay, so don't worry about the cloud provider, instead worry about the concept and the execution. Perfect. So this is a brief diagram which explains you what is Terraform actually. Okay, so if you still have any questions from yesterday's sessions and you did not understand, okay, why not we use AWS CloudFormation templates, and why should we only use Terraform, or why not we use AWS CLI? So if you look at Terraform, okay, what Terraform basically does is, as a user, okay, you configure a Terraform provider and Terraform will talk to the target API. What is a target API? So let's say you have provided your Terraform provider as AWS. Okay, what Terraform will understand is whatever the user has written, like the configuration files. So Terraform will convert these configuration files into the APIs that AWS will understand. And tomorrow, if you want to change your entire Terraform scripts into Azure, let's say, so what you will do is you will modify the script files and Terraform will do the rest of the things for you. You don't have to worry about, of course, you have to provide the variables, of course, you have to provide all the required information, but the templating language is the same. Okay, for example, if you look at AWS CloudFormation templates and if you look at Azure Resource Manager, and if you want to move from one place to another place, it's like you have to learn two different tools. Now, the options for the cloud providers is vast. You can today you can use AWS, tomorrow you might move to DigitalOcean, or tomorrow you might move to a world of hybrid cloud, like your organization might have few things in AWS and few things in Azure. So instead, if you just learn one Terraform, so Terraform, once you provide the provider details, it will understand that, okay, so this is the provider, let me convert the Terraform configuration files into APIs that AWS would understand, because AWS is your target. So it will convert your configuration files into target AWS APIs and your Terraform execution will takes place. So what you are achieving with this, you are achieving, you can manage any kind of infrastructure. Tomorrow if there is a new cloud that comes into play, let's say like Alibaba, tomorrow you have something called as XYZ cloud. So Terraform, or the module developers at Terraform, like the HashiCorp or the open source contributors, they will take care of writing these APIs. Okay, all that you need to do is, once they write the modules, you have to write the Terraform configuration files, and that's why you can manage any kind of infrastructure using Terraform, whether it is the existing clouds or whether it is the new clouds that are going to come in the future. Terraform will remain and will be the only tool that you have to learn. If you, if you want to move to Terraform, then track your infrastructure. That means to say, with Terraform, like you don't have to log into your cloud provider and see what is the infrastructure that you have created. Let's say you have an organization that is created by Terraform, all the infrastructure. What you can do is you can simply log into your Terraform machine, and you can look into the state file. If your state file is stored in S3 buckets or any other places, which is called as remote backends, which we'll learn going ahead, you can just go to your S3 bucket and see how does your state file look like, and it will explain your entire AWS organization. What are the resources that are created? Okay, so that way you can keep a track of your infrastructure. Then automate changes. What is automation of changes? So with Terraform, you don't have to, like, let's say you have to make one simple change. You don't have to manually log into your infrastructure and make the changes. Instead, you can automate, and similarly you can collaborate as well. Like whenever you want to make any changes, you can put this Terraform files except your state file. Okay, except your state file, you can put your Terraform files in a Git repository or any version control system. And what you will do is, using this version control system, you can collaborate with your peers. Like if you want to increase the let's say the resources of your EC2 instance, instead of manually changing it, you'll go to Git, you'll update your Terraform file, and you'll ask one of your peers to review it. Okay, so that they can review the code and they can say, okay, this is looking fine. So that way you can automate changes with collaboration. Okay, that's what I'm telling you here. And after that, you also have standardized configuration. Okay, so what is standardized configuration? Standardized configuration means, like, there is a standard that you are maintaining with TF files, right? So like manually when you're doing things, there is no standard. With one cloud provider, you will do things in certain way, and with another cloud provider, you will do things in different way. So instead, what you are doing is you are standardizing the way that you are writing the configuration. Perfect. So these are the advantages of Terraform. Whenever somebody asks you why you want to move to Terraform, so these are the things that you have to communicate. Perfect. And okay, you don't have to be explaining this with the same terms. You can just explain the overview. That should be more than enough. Okay, so after that, what is a Terraform lifecycle? Okay, so the reason why I'm explaining you in this step-by-step approach is, when we move ahead to install the Terraform and we move ahead to actually write the Terraform configuration, it should be useful for you. It will be useful for you if you understand what are we exactly learning with Terraform, right? So that's why I'm going to explain you about the lifecycle of Terraform. In general, what you will do with Terraform is you start writing your Terraform configuration files. So to write your Terraform configuration files, I agree that you might be very new to Terraform. So you might be wondering, okay, I'm pretty new to Terraform now. How should I start writing the Terraform project? Because it also follows a different indentation and syntax. Don't worry about it. Like just go to, okay, let me show you. Just go to HashiCorp Terraform. Okay, search for it in your browser. So Terraform by HashiCorp, and let's say that your provider is AWS. Okay, so click on the docs. Okay, uh, like instead, what you can also do is HashiCorp Terraform AWS. If you know that your provider is AWS, then you get AWS provider HashiCorp. Okay, so this is much easier, right? Instead of again going to the docs and finding out where the AWS docs are, you can directly jump onto HashiCorp AWS provider docs. Okay, now Terraform itself provides you a wonderful explanation of the documents. Like, if your Terraform is 0.13 or later, okay, which is the latest version, you can use the latest version, definitely. So this is how you start with. Okay, it says how to create your AWS provider, configure an AWS provider, where you are providing all the details. I'll explain you the files, don't worry about it, but just I'm showing you an overview that you can create any of the things with the examples that are given here. So Terraform provides you wonderful examples with detailed explanation. Let's say you want to create Lambda functions. Okay, even I don't know the syntax for Lambda functions. What I'll do is I'll come here. Okay, and I know that I want to create a Lambda functions from scratch. Okay, so AWS Lambda function, I'll come here. There is a resource that is available, and then there is a very good example which explains you how to create AWS Lambda function. Okay, so I'll just copy this example, modify the changes that I want to. Okay, so like maybe I want to modify the environment variables here, or maybe I want to modify the Lambda function name here. Okay, and what is the name of the lambda function? I can change all of these things. Okay, so it is very simple. But don't worry, I'll also explain you the indentation, syntax, what is written in each and every block. But just for now, what I wanted to explain is the first step that you would do is write Terraform configuration files, which is not at all difficult. Okay, just go to the HashiCorp Terraform documentation. You don't have to go anywhere else. Okay, you don't have to follow any videos for writing the Terraform files. Just go to HashiCorp Terraform documentation, search for the provider that you want to. Even tomorrow, if you want to move to Azure, you don't have to go to Azure and search for the Azure documentation. Just go to again Terraform documentation, search for the provider. You have each and every example of the resource that you want to create. And if there is, let's say there is a AWS function, or there is a AWS service which is introduced yesterday, and you don't find documentation here, that means to say, that itself mean to say that Terraform does not support that resource. Okay, then what is the next thing? Once you write your Terraform configuration files, before you actually execute, okay, because what Terraform does is, once you write the configuration files as explained here, Terraform will take the configuration files, create an API for it, and then submits the API to the target cloud provider. But what if you wrote something wrong? Okay, so in most of the tools does not support these kind of things, but Terraform supports something called as dry run. Okay, so what is dry run? Dry run is a way using which you can actually see what are the things that are going to happen when you execute. Let's say you have given mistakenly, okay, when you are writing your Terraform configuration files, you came here, okay, mistakenly you copied the as it is, like, you copied the exact example, and you forgot to change the environment variables. Okay, then if you run Terraform apply, your lambda function will be created with the same environment variables. But what Terraform provides you is an option to plan, okay, or option to dry run, using which you can understand, okay, so whenever I am going to execute Terraform apply, these are the resources that are going to be created, so let me correct myself. Okay, so if there is any mistakes, or if you want to look at the list of things that are going to be created, use Terraform plan, and then go ahead with Terraform apply. So this is entire life cycle. So firstly, you write configuration files, and then you use the Terraform dry run, and then you use the Terraform apply. And some people also consider Terraform destroy as part of the Terraform lifecycle, which is like just deleting the resources that you created with Terraform. Now, now that we understood what Terraform does, what are the different things that are involved in Terraform, what is the advantage of Terraform, we talked a lot. So let's go to the practical implementation and see how to install Terraform so that we can start playing with it. So I considered two things here. One is people with Mac, then or the other people which have Linux or installed Oracle VirtualBox, or created an EC2 instance on their Windows machine. Okay, because as I always suggest, either create a virtual machine on your Windows box or go with an EC2 instance, because so that you can play around with Linux in a real-time organization, or in a real-time scenarios. It is very unlikely that you would work on a Windows machine with Windows VM. So if you have Linux, go with this command. This is for Ubuntu. Now I'll also show you commands for the other operating systems. Don't worry. And then if you have a Mac, it is very simple. Just use the brew and install the brew target. That is for AWS. Sorry, that is for HashiCorp Terraform. So I have a Mac. So what I did was I used this brew install HashiCorp Terraform, and I installed Terraform. Okay. So if you see here, if I just do Terraform, so you'll find that, okay, Terraform is installed on my machine. Also, you can search for Terraform hyphen version. So what are the commands that I used? I simply use the brew tab HashiCorp Terraform to create the brew tab, and then I used the brew install. But what I got was, what I understood was I already had Terraform installed on my machine, but I was using an old version. So that's the reason why, if any of you already have Terraform installed on your machine, but for some reason, if you're using an older version of Terraform, then, please go with this specific option. Brew upgrade HashiCorp tab Terraform, so that you have a latest version. What happens is, some of the cloud provider modules might not work with old version of Terraform. So always have an updated version of Terraform on your machine. Perfect. So if you have different machine, or if you're on Windows, don't worry. Again, go to the HashiCorp Terraform documentation, and you can simply look for the ways to install Terraform. So click on Windows, so that they'll redirect you to a Stack Overflow article which explains you exactly how to install Terraform and how to put your Terraform in the path. And if you're on Mac, I already provided you the steps. Perfect. So this is how you install Terraform. Okay. So what if somebody is on CentOS, right? They also have steps for that. Let me also show that for you. Okay, where was it? No, not this one. Yeah, Mac or Linux. Oh, yeah. So the options are here. Either you can go with, these options that are present here, and then you can search for Ubuntu Debian. So this is the option that I've provided. Then you have CentOS. You can just follow this guide. Okay. So I'll also put the link in the description. Don't worry about it. So to install Terraform, do not go with the manual installations. Do not install with curl, because you might run into some issues with the path. Many people might not be experienced in installing the softwares and configuring them as part of path. And if there are any issues with the symbolic links, the soft links and the hard links, don't worry. Do not go into that, all of those things, and instead just use the native package managers. Like if you're on Mac, use the brew. If you're on CentOS, use yum. If you're on Ubuntu, use apt-get. Okay, so the documentation is very clear about these things. And once you install Terraform, okay, if you go to the previous slides, you just use this command called Terraform help, so that you understand, okay, if your Terraform is installed or not. Like for checking the version of Terraform, use Terraform hyphen version, okay, which I already showed you, right? So if you look at the Terraform version, I am on the latest version of Terraform, right? V1.3.7. So I'm already on the latest version of Terraform, so I can proceed with the next steps. Now what would be your next steps are? Once you install the Terraform, you should understand that Terraform basically runs on four commands. One is Terraform init, one is Terraform plan, which we discussed about, then Terraform apply and Terraform destroy. We talked about plan, apply, and destroy already. What is Terraform init? So Terraform init will initialize your Terraform. Like for example, here, if you see, okay, I think I'm already in a project. So I just clone the Git repository that I created, but let me move out and show you. For example, here I don't have any Terraform. And if I want to run the Terraform here, okay, I can show you here only, don't worry. So here I want to create my Terraform repositories, and I want to initialize a project here. So what I'll do is, wherever I have my Terraform files, okay, so here I have my Terraform file. There is one main.tf file that you will be going to write. What you can do is simply type Terraform init, okay, and let's see what happens. So Terraform will initialize AWS provider for you. Okay, so what Terraform is doing? Terraform is initializing you the provider that you want. Okay, so in your case, it can be Azure, or it can be GCP or any other things. Don't worry about it, but the command will be the same. So once you do Terraform init, okay, whatever you wrote in your main.tf file, the provider details, those provider configuration will be created in your local, and you will be able to communicate with that provider. Okay, so what are the four commands that you will use? Terraform init, plan, apply, and destroy. But saying that, what is the things that you're going to write in your actual Terraform file? Okay, so you understood that you will use Terraform init to initialize your provider. You understood that you will use Terraform plan to execute all of the things, or dry run, and Terraform apply to execute the things in real, and Terraform destroy to destroy. But how to actually write Terraform files before you do all of these things? So for that very own reason, I wrote a very simple Terraform to start with. Okay, so let us see that in a Git repository so that you have a better picture of it. Okay, so go to the AWS whenever you are starting with it. When you're starting with my repository, go to AWS, look for local state. Okay, so this is where you actually start with. Do not go with the remote state for the very first time. Start with the local state. And in the local state, I just wrote a very simple Terraform file that will create AWS EC2 instance. Okay, so this is a very simple file. Even you will find similar example. You might not find the exact example, but you will also find similar example from Terraform documents as well. Okay, like I explained you, You don't even have to follow my documentation. You can directly follow the Terraform documentation to start writing your first file as well. But why I created a repository and why I'm going to show you is because I'm going to explain you block by block what I actually wrote here and what we are going to create. Okay, so the first thing that you start with is you start with a Terraform block. Okay, so if you see here, all of these things like the resource provider, required resource, okay, they are falling under the Terraform block. So this is the actual thing that you start with. Okay, so if you look at the hierarchy here, what is happening is you have a Terraform block. Okay, so this is the Terraform block, and inside the Terraform block you wrote bunch of things. Okay, so start with a Terraform block. After that you provide the required providers. It can be a single provider or it can be multi providers. Like I mentioned you, in case of hybrid cloud you might use multi provider. In case of a single cloud you can just provide your AWS provider. Okay, so this reference, where did I get this information from? This information is a static information. Like, this information will remain same all the time, except the version might increase or decrease. Okay, Mm, it is very unlikely that you'll use a low version. Like if you start with 4.16 in your project, you always use 4.17 or 4.18 unless you have some compatibility issues with your existing files. Okay, so this information you can get from the AWS provider as well. Okay, so for example, this is the AWS documentation, right? So if you jump onto the AWS provider, the very first thing that you'll see is this one. Okay, so here they are using 4.0, and in my examples I'm using 4.16. I'm using a slightly higher version of the AWS provider. Make sense? So firstly, you start with the provider details. Without provider details, your Terraform is of no use. Whether you are writing AWS related information or any information, Terraform will only initialize your setup. Okay, whenever we were doing this Terraform init, what was happening is your Terraform init is actually looking for this required providers. Okay, so it understood that in my required providers I used AWS, so that's why Terraform init created the AWS configuration for me. Okay, so if you see here, what it did is it started installing HashiCorp slash AWS with this specific version. And then what it did is it said Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see any changes to your infrastructure. Okay, and you can then apply your changes to Terraform. So this is about Terraform init, or this is about the required providers block. And tomorrow, let's say you added one more block here. Okay, similar to AWS, let's say you added Azure here and you provided the Azure details as well, like what is the source, what is the version, and what is the source and version. That's it. So let's say you provided these details. What you need to do is you have to reinitialize your Terraform state. So to reinitialize, what you will do, just you will run Terraform init one more time. Okay, make sense? So this is about your Terraform initialization. And here we did not provide anything about the Terraform state file. Okay, I'll explain you what is state file, don't worry. But sometimes you also make changes to your Terraform state. Even in such cases, you have to reinitialize your Terraform. Perfect. Don't worry about state right now. Then required version of your Terraform CLI has to be greater than 1.2. You have to definitely write this block as well, because sometimes people will come to you and say that, Abhishek, I exactly cloned your repository, but it was not working for me. So in such cases, what you need to do is that you have to mention the version of Terraform, so that whenever Terraform is running your file, okay, whenever Terraform is going to do Terraform plan, or Terraform is going to do Terraform apply, even without plan, what Terraform will do is in your CLI, let's say somebody has cloned my repository and they are trying to execute this Terraform script, but it is failing for them because they are using a low version of Terraform or lesser version of Terraform. So Terraform will look into this specific block and says that, okay, the owner of the repository or the owner of this Terraform files have mentioned that the Terraform CLI version has to be greater than 1.2.0. Only then Terraform will work for them. Okay, so that's why provide the required version details as well. So what is the primary thing that you will write? The first thing that you write is the provider details. It always has to start with the provider details. After that, it should start with the required version. Once both of them are created, now you would move to the what is the region. Okay, these cloud providers, even if you don't use this block, that is still fine. Okay, so let's say you removed this entire thing, there is no problem. Okay, the reason for that is by default Terraform will choose the default region on your AWS, that is US East one. But if let's say that you created the provider, Terraform has initialized the provider for you, but you have some default configurations, like you only want your resources to be created in US East one, or you only want your resources to be created in US West one. So in such cases you can also configure your provider. Okay, so this is not a mandatory block. You can add any fields to this block, or you can just leave this empty. Perfect. Then once you provide all of these things, you can move ahead with the resources. Okay, what are the resources that you are going to create? Now this very own thing is the differentiator for each and every Terraform file that you are writing. All of these things are constant. Okay, so even in your project you can as it is copy these specific lines from my repository. There is no problem at all, but only things that would vary is these ones. Okay, so what is the resource information? What is the resource name? What are the parameters for the resource? Now these things you will get from the HashiCorp Terraform documentation. Okay, nobody will remember these things, and even if somebody is remember these things, it's not a good practice, because it will not help you anyways, right? What is the advantage of remembering this resource block for AWS VPC? Okay, let's say you remembered this one, you're not achieving anything, right? Because this is something that you can get from the documentation as well. There is no code involved in it, or there is no advantage of remembering these things. Even if somebody asks you in the interviews, you can say that I follow the Terraform documentation. I vaguely remember, or I do not remember the exact syntax, but I can try writing for you. Okay, so that even if you make any mistakes in writing these syntaxes, they will understand that okay, you have idea of how to write Terraform files, but you might not remember exactly the syntax for VPC. AWS has 200 services. Okay, so will you remember all of the syntaxes for this 200 services? Now Azure also has close to 150 200 services. So practically it will become difficult for people to remember the syntaxes for all of the resources. So everybody follows the documentation, don't worry about it. So once you do that, what is going to happen? Let's go back to the Git repository. Okay, so you can add a bunch of resources. Okay, so this is one resource that I'm going to create. Let's say tomorrow you want to create a specific along with the EC2 instance, you also want to add a load balancer. So what you will do is you will just modify this, and let's say I don't remember. Okay, for now I know how to create a load balancer, but let's say I don't remember. What I'll do is I'll come here, search for load balancer. Okay, let's say I want to add elastic load balancer. I'll just go here and look for the syntax AWS LB. Okay, your task, let's say your team has assigned you a task to add AWS load balancer creation to the existing Terraform repositories for a specific organization. You will go to the Terraform scripts, and what you will do is you will just go to the last part of your Terraform scripts, and just you will add resources regarding this one. Okay, so just copy the syntax from here. Do not copy exactly. Make the modifications that are required. If changes are required in variables file, if your organization is maintaining a variables file, you can make changes there. If your organization definitely organization will have input output variable files. Right now I'm not explaining them. Once you understand this entire thing, I'll also explain you about the input output variables. Okay, so it is always a good practice, like for example, here this thing, the name, or the load balancer configuration, the security group name, the subnet, the CADR block, all of these things should never be put inside the Terraform files, the main Terraform files or the resource.tf files. They should always go into the input.tf files, so that tomorrow, let's say somebody is going to modify these details, they don't have to come to the exact Terraform files, and they don't have to modify these things, right? So they can only go to the input.tf file, and they can update the details. Let's say you want to scale up your resource memory, or let's say you want to scale up your resource CPU. So instead of updating the Terraform TF files, like the resource.tf or the main.tf or any provider.tf details, they can only go to the input variables.tf file. It is just called input.tf mostly, and update the details. Even when you are reviewing the code, you will understand that somebody who is modifying these details in Git, okay, they are only updating the input.tf file, so it is less harmful for you. So okay, they're modifying the input.tf file. That means to say that they are changing some variables, so that you can look into the variable change and you understand, okay, there is no problem with it, right? So always good practice to maintain input.tf and output.tf files. Okay, so input.tf and output.tf is no rocket science. It's just you segregate your variables from these files and put them in different file names. Input is for inputting and output is for outputting. Like let's say you want to, let's say AWS EC2 instance is created and you want to show in the terminal what are the specific parameters of this EC2 instance that are created for you. So you can add those variables to your output.tf and Terraform will understand that, okay, you are expecting Terraform to show these details once the resources are created. Okay, so let's say for the EC2 instance, you want to get the private IP address once the instance is created. So private IP address depends on the AWS, right? It can allocate you dynamically any private IP address or public IP address. So what you can ask AWS is, instead of once the AWS instance is created, instead of logging to the AWS EC2 console and looking into that, you can directly put these details into the output.tf file so that Terraform will understand, okay, you are expecting me to share the private IP address. Okay, I don't have any problem. I'll print the output of private IP address. So this is how you make, or this is how you write better Terraform files by using input.tf and output.tf. Don't worry, uh, it's not a big deal. I'll also show you how to do that. Perfect. So we talked a lot about this Git repository. We talked how to write main.tf, what are the different things that are going to be used in this main.tf. Let us now execute. Okay, so I just have the same repository on my local. Okay, if you look at the path as well, I came to the write your first Terraform project /AWS/local state. Okay, so like I mentioned you, do not start with remote state because remote state has some advanced configuration. Perfect. Main.tf, to just show you that the things are same, let me just cat the main.tf, right? So it is exactly same whatever we discussed till now. Perfect. So Terraform init is already done. Let me do Terraform plan. So once I do Terraform plan, let's see what is going to happen. Sorry, it is taking some time. Okay, but it showed you what is Terraform going to create with this main.tf file. So it is telling you, see, Terraform prints everything in detail. Like if you see the details here, okay, there are bunch of things that Terraform tells you that using this one, resource AWS instance AP server, Terraform is going to use this AMI, which I have provided. Then the ARN, which is AWS resource name, that will be only known to you once you apply the configuration. Terraform tells you clearly the instance type is T2 micro, which is going to be created. And then Terraform tells you that this is the tag I'm going to create. These are the list of the tags. And everything that are going to happen once the Terraform creates this instance. Now, to actually run your Terraform apply and Terraform plan, you should get a doubt now that, okay, I'm doing Terraform apply, I'm doing Terraform plan, but how Terraform is able to authenticate to my AWS account? Okay, so you should have got this doubt by now. Like, because Terraform is just a CLI that is installed on your local, and AWS is a cloud provider. You just mentioned in your tf.main file, if you look at your tf.main file, sorry, main.tf file, what is there here? Just the required providers and the provider name. That's it, right? You just provided the region, no other details. So there is a prerequisite for Terraform that whenever you are configuring Terraform with your cloud provider, you should already authenticate it your sorry, you should already authenticate your cloud provider with your CLI. So in my case, I already have AWS CLI on my machine. Okay, so even in our previous classes, I showed you that I have configured AWS CLI, how to configure AWS CLI. I have already explained you, but if somebody is new to our class and let's say they only started with Terraform, so to authenticate Terraform with any cloud provider, it is essential for you. Like let's say you're using Azure. So you already have to configure your Azure service principal. Okay, without that Terraform will not work. So configure your Azure service principal first, and only then your Terraform will start working. So in case of AWS, you have to configure your AWS CLI first. So once you have your AWS CLI, and let's say I'm able to authenticate with my AWS, so I'll just do S3 ls, which is a very simple AWS CLI command. And if this is working, that means to say that your Terraform will also work. Okay, so to do this, how do you do this? If you are on AWS, the very simple command that you'll do is AWS configure. Okay, so if you do AWS configure, it will ask you for your AWS access key ID. Once you provide that, it will ask you for AWS secret access key. What is the default region? What is the default output format? And done. Okay, so if you're on AWS, this is a very simple command. If you're on Azure, I already made a video on how to create a service principal, how to configure the service principal, and how to execute the service principal. Okay, so it is going to be lengthy, so I'm not going to explain. But if you are interested, then you can watch the Azure service principal video on my channel. Now, if you're still confused on how to create these things, like you executed AWS configure, but you don't know how to use AWS access key ID and all of those things, you can again watch my previous video. But to just explain you in one simple line, just go to your AWS CLI. Okay, sorry, AWS UI. Where is this? Right. So if you go to your AWS UI or to your top right, you will find a settings page, and your icon, and beneath your icon, you will have something called as security credentials. Once you go to your security credentials, there is an option for access key as well as. Okay. So just scroll down. So you will find access key as well as your. Okay. This is a very section which is called access key. Okay. So here you can create your access keys and you can configure them in your CLI. Perfect. So we already understood Terraform init, Terraform plan. Now let us see Terraform apply, which will actually create resources on your Terraform. So let me show you if I have any EC2 instance or not. So if I search for EC2, we are creating an EC2 instance using Terraform. So before that, let me show you that I do not have any instances on my AWS account. Okay. So there are no instances in running state and there are no instances at all. Let me do Terraform apply and let us see what is going to happen. And remember that we were using US West 2. Okay, so let me also show you in the US West 2. So my bad, I should have showed you in US West 2 first, but no worries. So Terraform apply did not even start execution. Only when I click on yes, okay, then only your Terraform. Okay, there is one instance, my bad. Let me delete this instance. Actions and instance state. Let me terminate this instance. So it is good that I showed you, else you would have said that, no, you already have an instance. Just kidding. Okay, so it is shutting down. As you know, AWS will not take a lot of time to shut down, right? So the instance is already shutting down and it will move to the termination state in next few seconds. Perfect. So instance state is already shutting down. Now let me click on enter. Then it says yes. Let me see if it creates a new instance for me or not. So what is it saying? AWS instance app server is getting created. App server is the name that we provided. Still creating. Okay. So Terraform is right now converting your Terraform configuration files into APIs that AWS will understand so that it can execute these APIs and get the required action. See, if you see here now, a new instance is already getting created. This was the one that we were shutting down. I mean, that we just terminated. And this is the new instance that is getting created, right? So this is the instance with the same name, Terraform demo. And if you see here, now this is running. And in few seconds, this will get terminated. So if you can also find this instance ID on your CLI, okay, that Terraform just created for you. Like you see here, creation complete after 40 seconds, 47 seconds, and the name is, this is the instance ID. Okay, so this is how your Terraform will actually work. Okay, so using Terraform init, plan and apply, you just created a Terraform EC2 instance, EC2 instance on your AWS account. Isn't it very simple, right? This is very simple, right? And we explained all of these details using the slides, and you also have a GitHub repository so that you can try it by yourself as well, right? So if you want to try the local state, so all of these things are part of your AWS and then local state folder. So if you want to try things, you can just clone my GitHub repository or fork my GitHub repository, and you can find all of these things inside the main.tf file. Now, Now we will jump into some advanced topics. Okay, so this is about creating your EC2 instance and how to run your first Terraform project and all of these things. But once you understand these things, okay, now even if you do these things on your day one, that means you have learned a lot of things in Terraform already. But if you think that this is going too much in your very first class, you can stop the video here, and once you're comfortable with all of the things that we learned till now, you can come back and watch this video again. But for the people who have understood it and they want to understand further details of Terraform in the same class, now what are the things that we learned till now? Your Terraform apply is done. And if you see here, okay, let me explain you in a step by step way how to learn Terraform in advanced manner. Okay, so for the users who have executed this Terraform, they only got this thing, right? They only understood that, okay, this is the Terraform, this is the ID of the EC2 instance that Terraform just created for you. Okay, and they will understand going to the EC2 instance that, okay, this is the ID and I am fine with it. But let's say I don't even want to log into this EC2 instance, or there is a user who executed your Terraform scripts and he don't have access to the Terraform at all. Like, sorry, he don't have access to the AWS console at all. Okay, so he's just using a shared machine, or he's just using Jenkins, or he's using some pipeline, and he has executed your Terraform script. Now, just giving him the ID details will not be enough, right? He needs to know more about this Terraform EC2 instance. He needs to know what is the private IP address. He needs to know what is the public IP address, right? Because he is the user who has actually requested for this EC2 instance, and because he don't have access to the cloud provider, he used your Terraform using Jenkins pipeline, and he executed the EC2 instance. So for that reasons, you should create a file called as, okay, in this very own repository, you should write a file called as output.tf. Okay, so once you write output.tf, provide all the details, like what are the output that Terraform has to give you. Like for example here, you know yeah, where is this? Right. So here, Terraform just give you the instance ID. But similarly, you want to provide the users lot of other details, like his what is the private IP address of this EC2 instance, what is the public IP address of this EC2 instance, what is the key value pair so that he can log in. Okay, you have to give all of these details so that it will be useful for him. And even if you look at any repositories, like just go to your github.com and search for Terraform examples. Okay, so this is something that randomly came. I did not do anything here. And let's say, let us open one of the, okay, this is AWS here. Let me open this one. See here, they have a outputs.tf file. So this is a general practice and good practice of writing Terraform files. And let's see what is written in the outputs.tf. See, he has provided what is the API gateway invoke URL. So in this case, he is creating an API gateway. And if he does not know, like let's say you are a user, DevOps engineer wrote this, written this Terraform scripts. Okay, they wrote the Terraform scripts, and they just said that any user in the organization who wants to create API gateways, they can simply go to Jenkins, or they can simply go to this machine and execute your Terraform scripts. So they will execute the Terraform scripts as a users, but without getting the information of what is the gateway invoke URL, or without getting the information of what is the EC2 instance private IP address, public IP address, there is no use. So that's why as a user, you have to provide these things in the outputs.tf file. And similarly, if you have any variables, okay, so you can configure them in variables.tf, input.tf. Okay, so you can provide all the variables information. In the previous example, if you look at the main .tf, even this is a very simple Terraform file. We have hard coded a lot of things, right? What is the AMI? What is the instance type? All of these things can easily go into the variables files. Okay, so if you use them in the variables files, okay, for example, this is a variable, and here he is providing the default information. Okay, what is the default? He's saying index.handler. Then you can handle these kind of things. Okay, you can put them in variables.tf, and in your main.tf you can say that get these details from the variables, like this. Okay, so the indentation is very simple, like you use them in the shell scripting. You can just say dot dollar followed by the braces, and then you can say var dot ec2 instance name, or var dot memory size, var dot ami image name. Okay, so apart from this, apart from just writing the Terraform files, what you need to do is you have to write always your variables.tf, okay, and your outputs.tf, or inputs.tf and outputs.tf, so that you explain the user, whoever is executing this program, what is the output, okay, what is the information of the resources that are created, right? So this is one level of improving your Terraform scripts. Now, if you watch the execution very carefully, previously I created just the main.tf file, and I applied the configuration, and if you see here, this is the file that got created automatically. Haven't created this file. If you look at the Git repository, this file will not exist. So this is my repository. Let me go back to main.state. There is only main.tf file. This file is not there. Terraform.tf state. No, tf state. Now, what is this file? And this is the important file of your entire Terraform. Okay, you ask anybody about Terraform, the first thing that you will talk about is the Terraform state file, because Terraform entirely relies on this state file. Today, if I delete this state file, okay, Terraform will not understand that it has created an EC2 instance for you. So I told you already about Terraform, that Terraform is all about tracking the infrastructure as well, tracking the infrastructure. Now, what do I mean by tracking? This is exactly place where Terraform tracks the infrastructure. Okay, if you open this file and see, Terraform writes everything here. So Terraform, for its remembrance, or for it to in future modify the infrastructure, change the infrastructure, it writes everything that it created into this state file. Okay, so it says that, okay, I created one resource here. That resource is with this instance ID in the US West 2 and in the availability zone 2A. It has created one instance with one CPU, everything. Okay, so Terraform keeps a track of everything about this instance that it created. Okay, this is the instance ID. So that tomorrow, if you come here and say, this is my main.tf, right? So if I just say that instead of t2.micro instance type, or instead of one CPU, I want to increase the CPU to two CPU. Okay, and if I redo the same thing, like if I do Terraform plan and Terraform apply, then Terraform will make the changes to the infrastructure. So it will upgrade your CPUs to two, but Terraform will tell you that, okay, this is let me show you. Okay, for example, this is my main.tf. So this is just for showing you. Usually this will be in a very let me just change it to instead of T2 micro, let me just change. Okay, this is just for example. Okay, I just changed it to T1 micro, and let me just say Terraform plan. Now Terraform will explain you that, okay, you are doing Terraform plan, and this is the change that I'm going to do. Okay, so if you see here, it said one to change. Okay, plan, one to add, zero to change, and zero to destroy. If you see, if you actually the T2 micro and T1 micro is not a good example. Instead, if we had any resources, I would have showed you very clear, but don't worry about it. So what I am going to actually explain you, what I was about to explain you, that for any change that you're doing here, so Terraform should understand that you are making some changes to your environment or your AWS provider. So using this state file, Terraform will actually track all of the changes. Okay, so it has everything here, like all the sensitive information, non-sensitive information, information about your VPCs, EC2 instance. If some organization is managing entire AWS accounts using the Terraform, it will have information right from your CloudWatch to EC2 instances to VPCs, your KMS keys, everything, right? Because organization is entirely managing AWS using Terraform. So this is the main problem. Okay, although Terraform state is a very good one, okay, because Terraform state is the one that is keeping track of your entire infrastructure. But if you see here, right now what I did is I have executed Terraform from my laptop, okay, and it has created Terraform state file on my laptop and with open permissions. Okay, so it has read to all the users, so any user can come here and can read this state file. Okay, so you might ask me, oh, okay, this is not a big problem. I already know Linux, and I can simply change the permissions of this Terraform state file. Again, you can do it, but the problem is that how will you share this information? Like you have executed Terraform on your local. Let's say you downloaded this Git repository that I created. Okay. And let's say we both are working in one organization. Both of us, let's say, are working at Red Hat. And we are using this repository for creating infrastructure on AWS. Okay. So let's say that Abhishek, create a repository and we'll share the repository. So you downloaded this repository, you executed, and state file is created in your local. Similarly, when I execute, state file will be created in my local as well, right? So the problem is that this state file, okay, cannot be there are two problems. One is this state file cannot be uploaded to Git repository because it has a lot of sensitive information. It has secrets, it has information about your AWS VPCs, information about your KMS keys. So one is you cannot upload the state file into Git repository, and the other thing is you cannot merge both of the state files, right? So I have my own state file, you have your own state file. Because we both are using this Git repositories, we have to merge both of these state files and we have to put them into Git repository, which is again practically not possible. So that's why, even I explained the same things in the diagram. That's why you have to put the state file in one centralized location. Okay. You cannot, or you should never store your state files remotely. Okay. So this is a very first point that I explained about state file. You understood what is state file. Terraform uses state file to track everything that it created. And the main thing that you should never do with the state file is you should never store the state files on your local machine or even in Git repositories. Okay, you should always store these state files remotely in some remote backends. We'll talk about remote backends. Okay, but first of all, you should understand these 2 points. Okay, so let me even explain you one more time because this is very important. Terraform uses state file to track everything that it created. Let's say tomorrow you want to modify some things. So Terraform will only understand using the state file that, okay, I created this. Now I am updating this resource that I created yesterday. So everything is tracked using the state file. But the problem is that because it has a lot of sensitive information, it cannot go to a Git repository. And the other thing is, again, multiple people might work on the state file. I might clone the Git repository, XYZ person might clone the Git repository, ABC person might clone the Git repository. Now, sharing the state file or merging the state file, okay, somebody forgets to update the state file in Git repository, then your entire infrastructure is gone. Literally, entire infrastructure is gone, right? Let's say I executed the state file, some changes to my Terraform, and I forgot to update the state file in Git repository. Gone, right? So Terraform does not automatically update your state file to Git repository, and I totally forgot about it, and nobody else remembers that, or nobody else knows that I'm executing Terraform. So it's a biggest challenge with Terraform. So that's why never use Terraform state file on your local machine. Always also never do it in your source control. It can be Git, it can be Bitbucket. Never store them. Always store your state file in remote backends. Okay. So that is one of the biggest challenge with state files. And then do not manipulate the state files locally. Okay, what do I mean by do not manipulate state files locally is that some people try to change the state files on their machines. Okay, usually you don't have right access to it, but because I'm the owner of the state file, other people will not have access to it. But because I'm the owner, if you see here, I have read and write access. And if I try to update the state file, okay, then Terraform will get corrupted. Terraform will not understand, okay, that you updated the state file, or Terraform will not understand that, okay, something has happened. It will only think that I am using the right state file, and it will tell you that, okay, something is not correct. Let me fix the AWS infrastructure when somebody else is running it. So again, you are doing things wrong. So that's why do not manipulate your state file or do not update your state file by your own. So it should always be given read permissions only. Okay. So right now it has write permissions, right? So even when you're storing this Terraform in remote backends, which I'm going to explain you, always give only read permissions to the state file. Only Terraform should be able to update the uh, like state file. And isolate and organize your state file to reduce the blast radius. What do I mean by this is, uh, okay, let me explain you about the backend, and probably let me come back to this point and explain, because firstly people should know what is remote backend, and then I can explain you these things. So in ideal world, this is how your Terraform should look like. Okay, just give me a second. Sorry. So in an ideal world, this is how your Terraform should look like. So users will write Terraform scripts. Sorry, DevOps engineers will write the Terraform scripts and they'll store the Terraform scripts in a Git repository. So let's say I'm a DevOps engineer. I wrote the Terraform files and I stored the Terraform files in my Git repository. Okay. And there are users in my organization. Let's say there are users in Red Hat and the users want to use this Terraform scripts because what I did is as a DevOps engineer, I did not grant them access to the AWS infrastructure. I said, apart from DevOps team, nobody will log into AWS for some reason. Let's say, okay, let's say that nobody has access to create resources on AWS, and if at all they want to create resources on AWS, they should just use the Jenkins pipeline that I created, which will watch for the Terraform resources in GitHub. Okay, it will pull the resources, I mean the TF files from GitHub, and it will execute the resources on the AWS. And this person using the output.tf will get the information of your resources created on your AWS. Okay, let's say this is the process. But to this process, what I have added is, if you see here, I said that the state file would be stored in AWS Amazon S3. Right? What is this arrow here indicating? That I have entire Terraform configuration files. Like even if you see here, I just have my configuration files. Okay. But I don't have the state file here. So what is a good practice is always store the state file, not in Jenkins, not in GitHub. Always store your state file in Amazon S3 if you're using AWS. Okay. So if you're using Azure, you can store that in Azure storage container. So why we will store in Amazon S3? Because once you store your state file locally, you will run into so many issues. Even if you put that in GitHub, you have issues that I just explained you. If you put in centralized locations like S3, what will happen is anybody who is trying to modify, or anybody who is executing your Terraform scripts, the Terraform will automatically update the state file in centralized location, that is S3 bucket. Okay, and one more challenge that it addresses is, let's say there are two people who is trying to execute this Terraform scripts parallelly. Okay, so there are 100 people who are using this Terraform scripts, for example. Okay, sometimes it can be even more, and two users. Okay, in this case there is only one user, but let's say two users are trying to parallelly run this Terraform scripts. So Terraform should not allow that. Okay, if Terraform allows that, what will happen is, like, let's say they're giving conflicting information to AWS. So one is saying update the EC2 instance to 2 CPUs, and other is saying update the EC2 instance to 4 CPUs, and both of them are running parallelly. Now, what will Terraform do? Which instruction will Terraform take? Okay, so to avoid that problem, what you will do is that along with your remote backend, you will integrate your remote backend with DynamoDB. Okay, here DynamoDB is basically used for locking the Terraform state file. Okay, what does it do? It will lock your state file. So once it is locked, what Terraform will say that state file is locked. Some other user is actually using the Terraform scripts, or some other user is performing infrastructure configuration on your AWS resources. So wait until the configuration is done, and once the S3 is free, or once the resources in S3 are unlocked, which is your state file is unlocked, then I'll give you permissions to execute the Terraform scripts. So what is a good configuration, or what is the ideal Terraform configuration should look like? Always put your Terraform configuration files or your TF files in GitHub or in any kind of version control system, but your Terraform state file should go into remote backends. Okay, what is remote backends? Remote backends are nothing but your remote storage services. Like it can be Amazon S3 bucket, or it can be Azure storage container or something. Okay, so store that in your remote backends or remote storage solutions, and integrate them with proper locking solutions. Okay, so in this case, in case of AWS, the locking solution is DynamoDB. Okay, so you can use DynamoDB in Azure as well. Okay, but you can create your own DynamoDB and you can do that. Sorry for that. Okay, so AWS S3 with DynamoDB. Okay, once you integrate this locking mechanism, okay, what will happen is Terraform will not allow parallel execution of Terraform scripts. Okay, so this is the ideal Terraform setup that anyone should configure in their organization. There is no chance of excuses here. If you are even missing one of these things, okay, one of the things that I've explained here, only thing is you can replace Jenkins with any other CI solutions like GitHub Actions, or you can replace GitHub with any other VCS or version control systems like Bitbucket or Stash. I mean, Bitbucket, Stash, or GitLab or something. But you cannot change this flow. If you are changing this flow, then you are using Terraform in a wrong way. Okay, that's why I clearly mentioned that this is ideal Terraform setup. Now, this is the concept of remote backends. Okay, so what we did was, in the example we used Terraform in local state file, but in real time scenarios or in production scenarios, that is not how you deal with the things. You always configure a remote backend. Don't worry, I'll show you how to configure remote backend. Okay, before going there, I just wanted to explain you this point which I skipped in the previous slide, that is isolate and organize your state files to reduce the blast radius. So in any organization, usually you have multiple environments, right? You have unit environments, or some people call it UAT environments. People have staging environments. Then they have prod environments, or dev stage and prod environments. So it is always a good practice to isolate Terraform scripts for each and every environment. Like, for your dev, you have a different state file. Either you can segregate your Terraform scripts. Like for UAT, these are my Terraform scripts. For staging, these are my Terraform scripts, and for prod, these are my Terraform scripts, so that you have isolated state files. Even if somebody is messing up with the state files accidentally, incidentally, for any reasons, if they are messing up with the state files, you can reduce the blast radius, or you can reduce or implement the disaster recovery. So in such cases, always have your state files isolated. Okay, so these are some of the good practices with the state files. So this is very important, and these are the questions people usually ask in interviews for Terraform. I'll explain you when we move to the Terraform interviews question section as well. But okay, so before that, I'll show you how to do remote backend, because we talked a lot about remote backend. Now that I'll show you how to do remote backend. It's not a rocket science again. It is very simple to just your existing. Let's go back here. So here I have local state and remote state. Local state you already saw. If you go to the remote state, okay, so there is only one simple change. Okay, so in this case I also implemented outputs.tf. Okay, for somebody who wants to take a look at the outputs.tf, you can run both of them as is and they should work. If they are not working, just let me know in the comment section. I already tried the implementations, so they should definitely work. So if you go to the mains.tf, or sorry, main.tf of the remote state, the only change that I have done here, okay, if you see here, the only change that we do in the remote state is that we provide the backend details. Okay, so for example, if you okay, sorry, first you create the backend. Okay, so what I showed you in the previous slide is that I want to use Amazon S3 bucket and DynamoDB, right? Is it clear? So we should create Amazon S3 bucket and DynamoDB. What I did was, the only change is, in the existing flow, I created an S3 bucket. Okay, so this is the S3 bucket that I'm creating. Okay, in the local state main.tf, what I did, I just created EC2 instance. But here, what I'm doing is I'm creating S3 bucket. Okay, and then I'm creating a DynamoDB. Okay, DynamoDB table. So these are the two things that you have to do additionally from the previous main.tf or the local main.tf that I showed you, right? The local state main.tf. Once you do it, what you can simply do is, like, in your existing configuration, you can directly add these details as part of the backend. Okay, so let me show you that as well. See, if you see here, what we usually do is that, apart from the region details and apart from the AWS provided details that we are providing, what we do is that we just add, this is a Terraform block that I showed you initially, right? So to this Terraform block, you also add details of your backend. Okay, so in this case, what I'll do is I'll just come here, okay, to the main.tf. Once I create the S3 bucket and DynamoDB, what I'll do is to above this required provider, I'll just add the details of the backend. Okay, so in the GitHub repository, I already showed you. If you open this GitHub repository, I already showed you how to create S3 bucket and how to create DynamoDB. Once you create both of these things, once you execute the Terraform scripts by your own, all that you need to do is just come here and append the backend details as well. Don't worry, I'll also do that in the repository. Actually, I have it in my local. It just looks like I did not update the GitHub repository. That's it. So once I update the GitHub repository, you'll also see the details of how to implement the backend. Okay, so I just have it in my local. I thought I already pushed the changes, but looks like the changes right now are only to create S3 bucket and DynamoDB. But it's a very simple change. Just add this block of code where just provide that your backend is S3. What is your bucket name? What is your DynamoDB table name? Okay, that's the same thing that I'm creating in this as well. If you go to this GitHub repository, I'm just creating a DynamoDB table and I'm just creating a AWS bucket name. Sorry, AWS S3 bucket. Just provide both of those details. This region, encryption, and all of them are, they are not so important. And once you provide these things, your S3, your Terraform will be configured with the remote storage that is S3 bucket. Okay, so you will be able to implement this setup by just following my GitHub repository. I just need to make one commit more. Right now, I just have how to create S3 bucket and DynamoDB. I'll make that commit as soon as this session is done, so that you will be able to follow their end-to-end workflow for S3 remote backend using using Terraform. Perfect. So this is about remote backend. This is about local state file. What are the issues with the state file? What are some of the good practices with the state file and all other things? Now, there is one more topic that usually people ask in Terraform is Terraform modules, or there is something that you need to learn about Terraform is Terraform modules. This concept of modules is actually quite similar across multiple DevOps tools. Okay, so whether it is Jenkins, whether it is Terraform, whether it is any other tools, so the concept of modules is very similar. That is, whenever you have reusable code. Okay, so let's say in your organization you have a code for implementing EC2 instance plus ALB, okay, application load balancer, and you think that this code is used quite common. Or even if we take the same example, like the example that I'm showing you here, what I'm doing in this main.tf is I am writing a Terraform script for creating S3 bucket, and I'm writing Terraform script for creating AWS DynamoDB table, right? So I'm creating DynamoDB and S3 bucket. So in your organization there might be multiple DevOps teams, or you might be doing the same thing for multiple stages, like dev environment, staging environment, and production environment. So this happens to be a reusable code, right? Because you can use this code across multiple teams, or you can use this code across multiple environments. So in such cases, what you will do is that you will put this example. Okay, in this case I put this example in a Git repository, right? So you will start using this repository as a module, okay, inside other Terraform scripts or inside other Terraform files. So you will reference these things as modules in Terraforms. And once you reference them as modules, what will happen is before execution of these scripts, Terraform will start executing the modules. Okay, so that whenever you are trying to run the same example, if we take, whenever we are trying to set up Terraform, the users can worry about only writing the Terraform files. And if they just start using your example as module, what will happen is by default, they will have the Terraform configured with S3 remote backend and DynamoDB enabled. So there is a lot of effort that has gone, right? So with this, you avoid a lot of things by using modules. So modules is a way of writing reusable components, whether it is Terraform or Jenkins or any other thing. And what do I mean by existing modules? Existing modules are nothing but whatever the things that we were using. Even if you see here, we were using AWS S3 DynamoDB table. So by default, Terraform also provides some modules where you can create stacks or where you can use some reusable code. Now, once we discussed all of these things, it is essential for us to understand the problems with Terraform as well, because we talked about a lot of things in last 1 hour session, right? We talked about Terraform modules, we talked about Terraform state files, remote backends, remote states, configurations, advantages of Terraform. Let us also talk about some disadvantages, okay? Because even when interviewers asking scenario based questions during your interviews, they would be more interested in understanding the challenges that you faced with Terraform or problems that you faced with Terraform. So what are some of the problems? To start with, state file is a single source of truth, right? Whether you are storing it in a remote backend, whether you are storing it in your local machine, whether you are storing in a Git repository, it is always a single source of truth. So by any chance this state file is corrupted, whether you have misconfigured it, whether you have misused it, okay, or whether it is deleted accidentally, which is not the case usually, but let's say, okay, even if you're doing it in S3, the S3 supports versioning, and there is a lot of things, you can always go and get your old version of the state file. But let's say that you have misconfigured the state file, or you don't know how to use it in a good way, then you have compromised your Terraform state file. Once you compromise your Terraform state file, that means to say that you have messed up with your Terraform and your infrastructure, because state file is the heart of Terraform. Then manual changes to the cloud provider cannot be identified and auto corrected. This is one of the major challenges with Terraform. Let's say somebody during your production support, this happens very frequently. You can ask anybody who is using Terraform. Let's say somebody who is in a production support, or let's say somebody who wants to change AWS infrastructure, has access to your AWS. Okay, they manually modified some things to the Terraform. In our case, we created an EC2 instance using Terraform, right? Let's say somebody updated this EC2 instance on Terraform. Okay, knowingly, intentionally, or unintentionally. Now, Terraform is not bidirectional, or it is not a two-way communication. One is Terraform can look into the state file, and only when you update the changes in your local, Terraform will say that, okay, you are going to change the EC2 instance on the cloud provider, so let me update that. But when somebody modifies the resource directly on the cloud provider, Terraform will not know about it. And next time, when you try to update the resource, Terraform will say that, oh, okay, whatever I have in the state file is not same as the resource that is there in the cloud provider. Maybe somebody accidentally modified it. Now I cannot update it because there is a difference in it. Okay, so in such cases, you have to do Terraform refresh, or you have to manually update your state file using the Terraform refresh command. Okay, so this is one of the disadvantages of Terraform, because sometimes what if there are many changes that are made to the cloud provider, or I don't even want somebody to update changes into the cloud provider, right? I want Terraform to be bidirectional. If somebody make any changes to the cloud provider, even it's a EC2 instance resource or key value pair or something, I just want Terraform to automatically update it, right? That is how you expect a tool to be. But Terraform does not do that. The same thing is explained. It is not a GitOps friendly tool. Okay, so the same thing. If you follow the principles of GitOps, it is basically like, Git is your single source of truth. Whenever you have resources in your Git, like the same example, let's say I have used the Terraform file in Git repository. It is a resource to create EC2 instance, or Terraform files to create EC2 instance. Now somebody, when they modify some things on the AWS cloud itself, they updated the EC2 instance on the AWS cloud itself, they have access to it. Now the information is corrupted, right? Whatever you have in your Git is not single source of truth. There is a change in the Git repository. There is a difference in the configuration file in Git repository and your AWS EC2 instance, and Terraform is not automatically correcting it. So that's why it's not a GitOps friendly tool. So you might say that you can integrate it with any GitOps tools like Argo CD and Flux, but Terraform does not play well. At least there are some Flux controllers that Flux is developing for this Terraform, but I have tried them. They are not that user friendly at this point of time. And Argo CD does not have native support to Terraform even today. Then can become very complex and difficult to manage. Yeah, if you ask somebody who is managing Terraform with for 2 to 3 accounts, or for large AWS users. So Terraform does not play well because it has a lot of things that can be messed up. And finally, try to position as a configuration management, because these days the Ansible and Terraform are trying to cross paths each other. People create infrastructure using Ansible, people try to configure Kubernetes using Terraform. So the crossover is not that good, because the tools have to be natively for their own purpose, right? Terraform is built for configuration, sorry, infrastructure automation, infrastructure as code. Ansible is built for configuration management, but for some reason, um, I don't know the vision of the tools, or the vision of the developers or the maintainers, but it's not something good in at least according to me. I don't think that's a good practice. So if somebody asks you what are the problems with Terraform, you can definitely talk about these things. Okay, so just even if you try to remember these things and put the exact things with your interviewer, I'm pretty sure they'll be very impressed, because these are some of the practical problems with Terraform. Finally, Terraform interview questions. One is, I have done a full-fledged video on Terraform interview questions, and I have done a full-fledged video on problems with Terraform. So one is, you can either follow that video, and second thing is, even if you want to get interview questions out of this session, I have given you at least 10 to 15 interview questions while I'm explaining you. Okay, just for rough overview. One is, people can ask you, explain me some scenario where you had faced a problem with Terraform. Okay, you can talk about these things. Uh, what are modules in Terraform, which I already explained you. Okay, then people will usually ask you. This is one of the most common interview questions, that tell me about your Terraform setup. Okay, are you using your state file locally, are you using your state file in Git repository? So you should be able to explain them that, no, we use Terraform with S3 bucket as remote storage, and then we use DynamoDB for locking. So people also ask, what is the purpose of DynamoDB, why you have to integrate with S3 bucket? So you have to tell them that during the cases of parallel execution, the state has to be used by only a single user. So by using DynamoDB, you can introduce the mechanism of locking. That's how you can make only one person use the Terraform. Then, what are some of the good practices with Terraform? What are some of the Terraform state good practices? So we talked about a lot of interview questions, right? So one assignment that I would give you is, anybody who is watching this video, okay? So this is a very interesting assignment. Like, if anybody is watching this video, one is, follow this GitHub repository. Start with the basic example, right? Start with write your own project Terraform repository. Start using the local state. Build everything using the local state, like the main.tf example that I provided. Then move to the remote state, create S3 bucket, create DynamoDB. And once you do that, the task, the second task that I would give you is, prepare your own interview questions. Write your notes. Okay, what are the questions that I covered in this specific session, and what are the answers for yourself? And if you want, even I can review your questions and answers. Just put in the comment section that, Abhishek, I've prepared the interview questions as per the assignment, and I have stored them in a Git repository. Can you review them? I'll definitely review. And I always find it good if somebody is benefited out of my videos. You can also post them on the LinkedIn. Like, you can say that, I watched this video and I have got a clear understanding of Terraform. Now I prepared interview questions. I wrote a blog about the Terraform interview questions. Anybody who is uh, who wants to learn Terraform interview questions, then they can follow this blog, and even I can be a reviewer for your interview questions and answers. Okay, so this is a very detailed video on Terraform. It took a lot of time for me to prepare this entire slides and demo for you, and also the GitHub repository that I prepared. So please, if you like the video, click on the like button. If you have any comments, like good or bad feedback, definitely share them in the comment section. And don't forget to share these videos with your friends, whoever are interested to learn DevOps. And if possible, do post them about these videos in LinkedIn, so that you can also spread our channel with wider audience. Okay, so thank you so much. I'll see you in the next video. Take care, everyone. Bye.